Hello guys, welcome to another screencast. In this one we will be learning about how to solve 1 and 2 step equations. Now this is a review of 6th grade, but this one will actually include integers, so to make it 7th grade level. Okay, so it's really a review, except now we are going to be dealing with positive and negative numbers. Okay, so let's go ahead and get started. Alright, so first we are going to go ahead and start with one-step equation. Now, one-step equations. An equation is like a balance scale because it shows that two quantities are equal. So here's the balance scale. This is actually balanced. So if this one has 4, then the other one also have 4 as well. If I have 4 in here, there's also 4 in there as well. But if I go ahead and subtract 2 over here, I need to subtract 2 on the other side to make sure that it stays in equilibrium. So that's why when we are solving equations, whatever we do on one side of the equation, we need to do it as well on the other side. Okay, so here is an example. So we need to solve y minus 7 equal negative 13. What value can we plug in for y that will make this equation true? So we can actually work backwards. First thing we need to ask ourselves is, what is the variable? In this case, the variable is y. The next step will be to ask ourselves, what operation is being performed on the variable? So the variable is y, and here we are doing subtraction on the variable. Now, what is the inverse operation? How can we undo this subtraction? We all know the inverse of subtraction will be addition. And that is exactly what we will do to solve this. Okay? So here it is. So we are going to go ahead and add 7. Instead of subtracting 7, we are going to add 7 on both sides of the equation. And the 7's cancel, and I'm left with y is equal to negative 6. Okay, so once again, the variable here is y. Operation that is being done on the variable is subtraction. We need to make sure we do the inverse operation, which is addition. So instead of subtracting 7, we are going to add 7. Right, let's do another example. Here we have negative 6 times a equal 12. Please do not think that this is 6 minus a, where we are going to say, oh, we're going to add 6. No. This is multiplication. Okay, except now this is no longer just positive 6. It's negative 6 times a is equal to 12. So we ask ourselves again the same questions. What is the variable? The variable is a. What operation is being performed on the variable? And I just told you this is multiplication. Now, how do we undo this multiplication? And the opposite of multiplication will be division. And that's how we are going to solve. Instead of saying multiply by negative 6, we are going to do the inverse and divide by negative 6 on both sides. Okay, and a is actually equal to negative 2. Alright, so positive divided by negative, my answer will be negative. So we cannot forget the rules for multiplying and adding, subtracting integers that we learned in the beginning. We cannot forget those. So once again in here, this was negative 6 times a. To undo it, we need to go ahead and divide negative 6 on both sides. So once again, on both sides to keep everything balanced. Alright, one more example with one-step equation. Here we have b over 2 is equal to negative 10. This is actually division. This is b divided by 2 equal to negative 10. Remember, with division, we can write them the baby wing with the little division sign, or we can actually put them in fraction form. So here we will have we ask again the same questions. What is the variable? The variable here is b. What operation is being performed? I just told you guys that this is division. So how do we undo this division? We need to multiply. So instead of saying b divided by 2, since I have to work backwards, instead of divide by 2, I'm going to multiply by 2 on both sides. So here it is. We multiply by 2 on both sides, and the 2's cancel. They turn into 1. This is 2 divided by 2, which is 1. Bring down the b is equal to negative 20. Please do not forget about your negative sign. Okay? Now we are ready to move on to two-step equations. Alright, here is an example. Again, we want to ask ourselves the exact same questions, except here we are dealing with more than one operation. Okay, what is the variable? Of course, the variable here is x. What operation are being performed on the variable? Okay, now operations. That's why this is plural. We have a multiplication and an addition. This is 3 times x plus 2. So how are we going to undo these operations? We need to undo the addition, and we need to undo the multiplication. So we have to use the opposite, which will be negative 2. Okay, so here we actually have to do the opposite of plus and the opposite of multiplication. So we know we have to divide and then subtract. Okay, now the problem is here when it comes to two-step equations, some students usually get confused. What do we undo first? Do I go ahead and divide by 3 first, or do I subtract by 2 first? Now I'll let you know right now. Whatever is attached to the variable, in this case the 3x, the 3 is attached to the x, so we want to save it for last. Okay, so also remember we are doing Pemdas backwards. Okay, so usually if we were going to solve this, if we knew what x was, we will go ahead and multiply and then add. Okay, we will multiply first and then add. So now we have to do everything backwards. So to undo this, we need to first undo the addition by subtracting, and then we undo the multiplication by dividing. Okay, you guys see how we're working backwards here? Normally, if I knew what x was, I would do, let's say, I'm just going to make up a number. Let's say x was 1. Okay, so we'll do 3 times 1 plus 2. If we were going to solve this, if we knew what x was. But since we do not know what x is, so we need to work backwards. Instead of multiplying first, we are going to undo the addition first, and instead of adding second, we are going to undo the multiplication as our second step. Once again, why are we doing that? Because we are working backwards. So let's go ahead and undo the addition. So this is plus 2. Let's go ahead and take away the plus 2 by doing minus 2. And we bring down 3 times x is equal to negative 6. Remember, same sign, add and keep. Now 3 times x, we undo it, we need to divide by 3, and x is equal to negative 2. I'm dividing a negative by a positive, so the answer will be negative. Okay, now let's move on. So here is another example, but with this one I'm actually going to show you what happens when we model this with the tiles. So here we have 2 x's. We're trying to figure out how much is each one worth, and we have minus 1 is equal to negative 3. Now if I'm trying to figure out how much is each bar worth, what I really need to do is to get rid of this negative 1, right? So the only way to get rid of the negative 1 is to add a positive to it. Remember, a minus and a positive. will cancel each other out. Those guys are opposites, so they will cancel each other out. So if I add one positive here, I also need to add a positive on the other side. And this one is going to cancel, that one and that one's going to cancel each other out. Okay, so now I'm left with 2x is equal to -2. So how much is each one worth? So I have to split them, which is dividing them. So once I divide them, then I can see that each one is worth -1. Okay. Right, let's go ahead and do this one very quickly. Again, we need to ask ourselves the exact same questions. What is the variable? The variable is x. What operation is being done on the variable? We have a times and we have a plus. How do we undo these? So we need to subtract and we need to divide. Okay, so now let's go ahead and do this. Okay, so here first thing we need to do, remember, whatever is attached to the variable, we save it for last. Okay, so first thing we need to do is to get rid of the 4. So we need to subtract 4. Since 4 here is positive, we need to turn it to negative. Break down 3x. 1 minus 4 will be -3. And then since this is times, so the opposite of times will be to divide by 3. And we are dividing by a negative, positive, so my answer will be -1. Right? Very easy. Alright, one thing to watch out for is this one. Now in this example, it's not written the normal way. Usually it's 3y minus 6. But remember, with subtraction, we cannot commute. So I cannot move this around and say this is 3y minus 6. The best thing to do, remember I told you guys again, whatever is attached to the variable, we want to do it last. The exact same rule apply here. We want to do this last. Okay? Now, this 6 here is actually a plus. This 6 here is positive. Remember, whenever you don't see a symbol in front of the number, there's actually a plus there. So this is plus 6. Let me put it in different color. So this is actually plus 6. Now, whatever is attached to the variable, this one we're saving it for last. Okay? Now, how do we get rid of the 6 then? Move it to the other side. We need to subtract. Why am I subtracting 6? Because this is positive 6, so I need to add its inverse, so which will be -6. Alright, now -6 and positive 6 cancel each other out. Be very careful. Now I'm going to bring down 3y. But 3y here is actually negative. So I need to make sure I bring down -3y. Do not forget the symbol. Do not forget the symbol. -3y is equal to -9. -3 minus 6 is -9. Now I can go ahead and do the second step, which since this is -3 times y, opposite will be to divide by -3. Not just 3, by -3 on both sides. The 3's cancel and y is actually equal to negative. We're dividing two negatives, so my answer will be +3. Okay, so once again, watch out for this one. We could do it the other way by moving the 3y, but I'll show you guys that in class because that can take a little longer. Okay, so let's go ahead and move on. And hopefully you guys now are ready to do some practice. Alright, go ahead and try these. Go ahead and try them, pause, and then come back, and then I will reveal the answer. Alright, welcome back. So here are the answers. Number 1 will be -8. Please do not forget your negative sign. Otherwise, your answer is incorrect. Number 2 is 6. Number 3, -2. 4 is 1, and 5 is -3/2. Now for number 5, just because we did not end up with a perfect number, that's fine, because we all do know now that rational numbers do exist. They're numbers too, so there's no need to be afraid of them. Okay, so hopefully you were able to solve all these by yourselves. If you have any question on how to solve these, please send me the question through Edmodo, and I will help you through it with any of the problems, or you can actually write them down and put a question mark next to the one you have a question for, and then we can go over it in class. And that was it for today, so hopefully you didn't find this too difficult. You have a good one. Bye bye.